This is a video showing you how to do linearization practice number 1. Number 1 states, students measured the area of a circle as they increased its radius. So they're changing the radius. That's going to be the independent variable. That'll go on the x-axis. And then they measured the resulting area, which is the dependent variable, going to be on the y-axis. I've already typed in my data and included units. So I'm going to graph it. And I need to switch my axes here because radius needs to go on the x-axis. And area needs to go on the y-axis. And I see that it's a quadratic shape. If I put a linear fit on this, it'll make that even more clear. Our over-under pattern, we have over, over, under, 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 and then one over again. The data is clearly curving upwards. So we need to linearize it. And if we go to our notes, we need to square the x-axis. So we need to do the radius squared. So to do that, we are going to make another column, and we're going to rename that radius squared. And the units are just the units that we had before, but squared. So now they're going to be centimeters squared. And then we just need to square each of these numbers. So 1 squared is 1, 3 squared is 9, 7 squared 49, 1, and so on and so forth. You want to square each thing. So 169, 256, and 400. And now we want to graph it. And we can, if we want to compare, we can show both of the original graph and the linearized graph. Or if we just want to show one graph, we can just go back to one graph. So no change because it's still radius on the x-axis and area on the y-axis. So we need to select the x-axis and we need to select radius squared. We want to get rid of this old line of best fit because that's not useful. So you tap that gray box where it says 20 centimeters squared, and then you can hit the delete key. You want to make sure you are auto-scaling this correctly. Let's see, if you double tap the screen, it auto scales, or if you double tap again, it goes back to like a 10 by 10. And then we're going to highlight, and we're going to do a linear fit. And our correlation went to 1. So if we wanted to look at both graphs at once, I can do 2 graphs. And I can do area, radius versus area. And so we can clearly see the top one is very linear, and the bottom one is quadratic. Again, if you want to compare the correlation coefficients, well, the correlation coefficient on the quadratic one is still good, 0.965. You got to look at that data and realize that is clearly not linear. It's clearly curving up. This is another reason that you want to take lots of data points, and you want to get a good range. You want to be extreme. You want to get really small values, and you want to get really big values. On the worksheet, what you would draw is you would have a sketch without the linear. For the original graph, you would actually kind of do the quadratic one on there. So your original graph would have what's on the bottom of the screen, and then the linearized graph, the one on the right, would have what's on the top of the screen. Now to write a physics equation from this, we want to do the y equals mx plus b part for the linearized graph. So that's the top one, that's the red one. So instead of y, we have a for area. Instead of x, we have r squared for radius squared. You've got to remember that squared. For m, you can look in the little statistics box. That's 3.146. And for b, that's the y-intercept, it's negative 1.514. The units for those numbers, for the slope, the 3.146, the units of the slope are the units of the y-axis, centimeters squared, divided by the units of the x-axis, centimeters squared. It's always units of the y over units of the x, because slope is rise over run, change in y over change in x. And centimeters squared over centimeters squared actually cancels out, so there actually won't be units there. And for the y-intercept, the units of the y-intercept are always just the units on the y-axis. So in this case, it would be centimeters squared. So your final physics equation should be A equals, and then in parentheses, 3.146 centimeters squared over centimeters squared, and then close parentheses. And you can cross out the centimeters if you want. And then r squared minus 1.514 centimeters squared. And that's your final physics equation. And that is how to do number 1 on the linearization practice worksheet.